All right, so when we look at the first one here, since they are both the same functions, they both have x squared and y squared, we're going to use the elimination method. So if you recall back in Algebra 1, if I put a plus sign here, can one of these variables cancel out? Which one? Y. So x squared plus x squared is 2x squared. That cancels, because that equals 0, equals 13 plus 3 is 16. So now we're going to go ahead and solve for x. So we're going to have to divide both sides by 2. We get x squared equals 8. And then we're going to square root both sides. So x equals plus or minus 2 square root of 2, because we want to simplify square root of 8. So now in this particular situation, we have an x equals, and we have two outcomes. Remember, when we are solving nonlinear systems, we're looking at the point where they intersect. So we have two x's. So we have 2 square root of 2 and negative 2 square root of 2. So now we got to go back and find y. Okay? So we can plug it into the first or the second. I'm going to go ahead and plug it into the first one. So now I'm going to stop you for a second, and I want to explain what I'm about to do. So if I was to plug in and substitute 2 square root of 2 for x, most of the time when I put this here, students will try to do mental math and they will end up getting the wrong answer. You could, of course, put this in your graphing calculator if you want, but if you were to square this, you have to square the 2 and the square root of 2, which would give you 2 times 2 is 4 times 2 is 8. Okay? So what I've had students do is take the one before it's simplified and plug it in, because square root of 8 is 2 radical 2, right? So if you take square root of 8 and you square it, you know the square root of 8 times square root of 8 is what? So it'll kind of eliminate you from making a mistake here. Okay? So I'm going to use that to plug in. No, so now square root of 8 squared, that means square root of 8 times square root of 8 is just 8, plus y squared equals 13. We'll subtract both sides by 8, and y squared equals 5. And now we square root both sides, and y equals plus or minus square root of 5. Remember, whenever you square root both sides, you have a plus or a minus. So now, when I plugged in a positive square root of 8, which is a positive 2 square root of 2, I get two answers. So 2 square root of 2 equals a positive square root of 5, and 2 square root of 2 equals a negative square root of 5. So remember, when I showed you this on Desmos, this is a circle, this is a hyperbola, so you have 1, 2, 3, 4 points of intersection. All right, so now I've got to plug in the negative 2 square root of 2, okay, which is basically negative square root of 8, right? Well, if I just change this to a negative, and when I square it, won't it give me a positive? So I don't have to do all this work all over again. I just know that the result again is going to be plus or minus square root of 5. So when it's negative, I get a square root of 5 and a negative square root of 5. So that's how you find those 4 points of intersection. All right, let's go to the next one here. Here we have two conics. We have a circle here, x squared, y squared, which again is probably going to be a hyperbola right there. So we know that we can have at most 4 solutions. So since these are x squared, y squared, they're the same function type, we can use elimination method. So if I put a plus sign here, My y's will cancel out. So 1 minus 2 is negative x squared. This cancels. 6 minus 7 is negative 1. We're going to divide both sides by negative 1. X squared equals a positive 1. Now we square root both sides. X equals plus or minus 1. So I have an x at 1 and I have an x at negative 1. So now to find the y value, I have to plug in 1 in one of those equations. Don't automatically think because this had 4 solutions that I go ahead, that everything has 4 solutions. You know, you have to do the algebra to make sure it makes sense. So we're going to plug in 1. We could do the first or the second. I'm going to do the first. The x squared plus y squared equals 6. If I plug in a 1, 1 squared is 1 plus y squared is 6. We'll go ahead and subtract 1, and y squared equals 5. We'll square root both sides. Y equals plus or minus square root of 5. So now when I used x is 1, I got 2 outputs, a positive and negative 5. So 1 gives me a square root of 5 and 1 gives me a negative square root of 5. Now somebody asked me, can you just put plus or minus 1 and plus or minus square root of 5? You have to show all the work to back it up. So list them separately so they recognize that 4 individual points. If I plug in negative 1 up here, will it give me the same answer? Yes, because if you square negative 1, it gives you a positive. We don't have to do this work all over again. We have to get the same thing. So square root of 5, negative 1, negative square root of 5. All right, on number 3 is going to be similar. You're going to do this on this blue paper that I give you when you work in groups, but I'm just going to start you off with this. Same thing, same type of functions, x squared and y squared in your constant term. The only problem with this is nothing's going to cancel out if you try to add these two together, right? So we need to multiply something to one of these equations or both to get something to cancel out. So if I want to cancel out the x squares, that's a 2, I need a negative 2. So it would be really easy to just multiply everything by negative 2. If I wanted to do the y squares, well, that would take more work because I'd have to change them both to 6, one negative and one positive, so we'd have to multiply both equations. So the easiest thing is to cancel out the x squares. So I'm going to start you off. We're going to multiply all this by negative 2. So the first function will stay exactly the same. And then this one will distribute the negative 2. And I'm not going to finish this. When you're in groups, you'll finish this. That will start you off. And then you can eliminate the x squares. Okay? All right, let's go to the next one. Let's go to number 4. So on number 4, you have a circle, and 2x minus y equals 1 is linear. So when I tell you to use, to critically think about these problems, look at it and see what's the most amount of solutions you can get with, let's say, a circle and linear. 2. So you can't have 3 or 4. That's not possible. Okay? So when they're not the same, you use substitution. So we're going to go here. And when you have one that's linear, you always want to solve for y. So let's go ahead and take this, and we're going to solve for y. So I'm going to subtract 2x to both sides. I have negative y equals negative 2x plus 1. We're going to go through and divide everything by negative 1. And we have y equals 2x minus 1. So I'm just going to copy this over just to make the notes look a little bit more cleaner. And then this is y equals 2x minus 1. So we're going to forget about this now. This is what we're looking at. So now we're going to take y, this is y, and we're going to substitute it in there. So we have 2x squared plus 2x minus 1 squared equals 11. Now remember, when you take 2x minus 1 and you square it, don't square each and say it's 4x squared minus 1 or plus 1. That's not correct. I'm going to go down here. You have to FOIL this. So 2x minus 1 times 2x minus 1. So we're going to distribute. So I'm going to replace 2x minus 1 squared with 4x squared minus 4x plus 1 equals 11. So let's go ahead and combine like terms. This gives us 6x squared minus 4x plus 1 equals 11. Now this is quadratic, so in order to solve a quadratic equation, we have to set it equal to 0 and solve by factoring or quadratic formula. So I'm going to subtract both sides by 11, and we get 6x squared minus 4x minus 10 equals 0. Now before I factor it, what should I do? GCF, correct. Divide everything by 2. Is that what you said?
No, I did.
Divide everything by 2. Let's make these numbers smaller. We don't want to go straight to A times C method. So we're going to divide everything by 2. There's no x with that 2, so we just get rid of the GCF. Now we're going to factor. You could do A times C method, but I'm going to go ahead to save time. I'm going to factor using guess and check, because 3x times x give you 3x squared. For 5, it's only 5 and 1. Negative 5x plus 3 is negative 2. Now go ahead and set both of those equal to 0 and solve, and you get your 2 x's. X equals 5/3 and negative 1. So those are my x values. So now we're going to plug it in, and be easier to plug it in this one here. So y equals 2 times x is 5/3 minus 1. So just take your calculator. And you get 7/3. And now we're going to plug in negative 1. And 2 times negative 1 is negative 2 minus 1 is negative 3. All right, let's look at this last one here. Now you have like a conic, or let's say a circle, and you have, what type of function is this? Is this linear, quadratic? It's quadratic. So now let's say if we have something quadratic and like a conic circle, or even if it went that way, you can have at most 1, 2, 3. Again, we can have at most 4. Doesn't mean we're going to have 4. We could have 2. We could have 3. We could even have 1. But at most 4. So the thing is, and I want you to watch this right here. If I solve for y, don't write this down because I'm not going to solve for y to solve this equation, and I get 1 minus x squared, I would have to plug that in for y up here, which would give you something like, so when you'd FOIL this out, you'd have x to the fourth, right? You'd have x to the fourth, and then you'd have a higher polynomial. Then you're going to have to go through that whole process, what I taught you in Unit 3, and it creates a lot more work. So instead, we're going to solve for x squared. So if I subtract y, x squared is 1 minus y. So I'm done with this. So let me show you what you do with this. I'm going to replace this entire x squared with 1 minus y. I'm not going to put 1 minus y in parentheses and then squared. I'm replacing the entire x squared with this. Now you could solve for x and square root both sides and then plug in the square root of that, and if you square it, it gives you 1 minus y. Or you just leave it x squared and replace the entire x squared. Do you understand what I'm saying here? Okay, so now we're going to distribute. It's quadratic, so we're going to set it equal to 0, so I'm going to add 6 to both sides. Then I don't like the order this is in if I want to factor, so I'm going to rewrite in standard form so that this term comes first, right? So I have negative 2y squared minus 3y plus 9 equals 0. Now we're going to divide everything by negative 1 because I don't want this first term to be negative. All right, so now we're going to do the a times c method here. Does 2 times 9 give me 18? Are there factors of 18 when I subtract give me 3? Yeah, 6 and 3. It's factorable, so let's factor it. So y squared plus 3y minus 2 times 9 is 18. Let's go ahead and factor it. Y plus 6, y minus 3. And then we go back and divide by a. I'm going to leave this as a fraction because I'm solving for y anyway. Who asked me that? I teach them a different way to factor. When you were with Ogle, she teaches it differently. So you just factor the way that you've learned it, which I think you do it splitting the middle term. Yeah. So when we solve, we get y equals negative 3 and positive 3/2. So that is y, so we make sure we put it where the y is. When I try to find x, will it be easier to plug negative 3 in this new equation that I solved or that original? Or that first one here? It'd be easier for this one because I say x squared equals 1 minus y is negative 3. Well, that's x squared equals 4. And when I square root both sides, x equals, I get two outcomes, plus or minus 2. So when y is negative 3, I get a 2 and I get a negative 2. Now I'm going to plug in the 3/2. So we have x squared equals 1 minus 3/2. When you put 1 minus 3/2 in the calculator, tell me what you get. Negative what?
Negative 0.5.
Negative 0.5, basically negative 1/2. And what happens when you try to square negative 1/2? Well, if you try to square root negative 1/2, you get error because you can't square root a negative. It doesn't exist. Now, we learned in Unit 3 that we can use I, but remember I is the imaginary number. It's a number that does not exist, which means this point does not exist. No, because if it's imaginary, it doesn't exist. It's not a real number. So you don't put I there because we've learned that you can solve any equation. Okay? It's like when you have x squared plus 4 equals 0. If you were to graph that, it's up here. There are no zeros. And then if you try to solve that, you subtract 4, you square root a negative. That's plus or minus 2i. We've learned how to replace negative square root of a negative number with I, but it doesn't exist. There are no x-intercepts with this. So same with this. When it comes out to be a negative, it's not going to intersect anywhere when y is 3/2. Okay, so those are your two solutions.